Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem. Solve d square minus 2d plus 5 into y equals 3 power 2x into sine x. Let's find order and degree of the differential equation. Identify the highest derivative. Here d square is the highest derivative, so r0 will be 2. And highest power of the highest derivative is a degree. Degree is 1. Now, or you can write the given differential equation as d square y minus 2dy plus 5y equals 3 power 2x sine x. We know that d is a differential operator. Then d square will be d square by dx square. Now we can write our differential equation as d square y by dx square minus 2 into dy by dx plus 5y equals 3 power 2x sine x. Right? Identify the highest derivative here. D square y by dx square is the highest derivative, so order will be 2, and the highest power of the highest derivative is the degree. Degree is 1. Right? Now coming to the problem. Given differential equation, d square minus 2d plus 5 into y equals 3 power 2x sine x, which is an operator form. F of d into y equals to q, where f of d equals to d square minus 2d plus 5 and q equals to e power 2x sine x. Now we need to find the general solution of the given differential equation, which is given by y equals to yc plus yp. Here yc is a complementary function. We'll find yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by putting RHS to 0, we'll get f of d into y equals to 0, a homogeneous equation of the given non-homogeneous equation, and we'll find yp using 1 by f of d into q. Right? So let's begin with yc. Now we are going to find yc using the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square minus 2d plus 5. Let's replace differential operator d by m, so that we'll get f of m equals to m square minus 2m plus 5. Now our auxiliary equation becomes m square minus 2m plus 5 equals to 0. So here we are going to find roots using quadratic formula. M equals to minus b plus or minus square root of b square minus 4ac by 2a. Now compare the auxiliary equation with am square plus bm plus c equals to 0, where a equals to quotient of m square 1 and b equals to quotient of m, which is minus 2, and c equals to 5. Now let's find roots using m equals to minus b plus or minus square root of b square minus 4ac by 2a. This is equals to minus b, minus of minus 2, plus or minus square root of b square minus 2 whole square minus 4ac by 2a, which is equals to minus into minus plus 2 plus or minus square root of minus 2 whole square is 4 minus 4 5s are 20 by 2 1s 2. which is equals to 2 plus or minus square root of minus 16 by 2. This is equals to 2 plus or minus. We can split minus 16 as minus 1 into 16 by 2, which is equals to 2 plus or minus. Now split square root of minus 1 into square root of 16 as square root of minus 1 into square root of 16 by 2. Right? Since we know that square root of minus 1 is I and square root of 16 is 4. So we can replace square root of minus 1 with I and square root of 16 with 4 by 2. Now take 2 common from the terms of numerator. You'll get 2 times 1 plus or minus 2i by 2. Right? 2 gets cancelled. So this equals to 1 plus or minus 2i. A pair of complex conjugate roots. Therefore, m equals to 1 plus or minus 2i. Therefore, m equals to 1 plus or minus 2i are the roots of our auxiliary equation f of m equals to 0, which is a pair of complex conjugate. We know that a plus ib is a complex number, then its conjugate will be a minus ib. If a minus ib is a complex number, its conjugate will be a plus ib, right? So we can call a plus or minus ib as a pair of complex conjugate. So we got complex conjugate roots. So yc will be e power ax into one constant into cos bx plus another constant into sin bx. Now let's write our complementary function. Our complementary function looks like this. E power 1 into x into c1 cos 2x plus c2 sin 2x, right? Then yc equals to e power 1 into x is x into c1 cos 2x plus c2 sin 2x. Now we got yc. Let's find yp now, particular integral. We can find particular integral using 1 by f of d into q. We have f of d square minus 2d plus 5 and q is e power 2x into sin x. This is of 1 by f of d into e power ax into v form, right? Now compare e power 2x with e power ax, and for a equals to 2, we need to find d plus a, which is given by d plus 2, right? D plus a for a equals to 2 will get d plus a equals to d plus 2. Now, we have to shift e power ax towards left by replacing d by d plus a into v. And later we'll operate v with 1 by f of d plus a, right? Is equals to shift e power 2x by replacing d with d plus 2. We'll get d plus 2 whole square minus 2 into, again replace d with d plus 2 plus 5 into sin x, right? Is equals to e power 2x into 1 by expand d plus 2 whole square using a plus b whole square formula. D square plus 2 square 4 plus 2 2s are 4d minus 2d minus into plus minus 2 2s are 4 plus 5 into sin x. Our yp becomes e power 2x into 1 by d square plus 4d minus 2d is plus 2d. Here plus 4 minus 4 gets cancelled and you'll get plus 4 into sin x. See here the term under bracket is of some 1 by function of d, some function of d into sin ax form, right? Otherwise this is of a known form. This is a known form, right? 1 by f of d into sin ax. Now for a equals to 1, we need to find d square, which is given by minus of a square. This is equals to minus. For a equals to 1, you'll get minus of 1 square, which is equals to minus 1. Right? Now, what we'll do is, we'll replace d square by minus 1. Always remember that the denominator must be non-zero. If we get the denominator 0, then 1 by 0 into sin x becomes undefined, since 1 by 0 is undefined, right? Let's see what happens if we replace d square by minus 1 in the denominator. Just take the denominator part and replace d square by minus 1. We'll get minus 1 plus 5 is 4 plus 2d, which is non-zero. Since by replacing d square by minus 1, the denominator becomes non-zero, so we can dare to replace d square. Replace d square by minus 1. Then we'll get 1 by minus 1 plus 2d plus 5 into sin x is equals to e power 2x into 1 by minus 1 plus 5 is 4 plus 2d into sin x, right? Now let's take 2 common from the two terms of denominator for our convenience. Okay, we'll get 2 times 2 plus d, right? 2 into 2 4 plus 2 into d 2d into sin x. Now take 1 by 2 outside the brackets, then we'll get e power 2x by 2 into 1 by d plus 2 into sin x. Either you can write d plus 2 plus d as d plus 2, or you can just write 2 plus d. Okay, better I write the same thing, 2 plus d. Now we are having yp equals to e power 2x by 2 into 1 by 2 plus d into sin x, right? Is equals to e power 2x by 2 into 1 by 2 plus d. Here, if you notice, in the denominator you are having 2 plus d. Just change the sign, plus to minus, then we'll get 2 minus d, right? Now multiply and divide the fraction with 2 minus d into sin x is equals to e power 2x by 2 into 1 into 2 minus d is 2 minus d by 2 minus d into 2 plus d. Sorry, 2 plus d into 2 minus d into sin x is equals to e power 2x by 2 into 2 minus d by this of a plus b into a minus b form, so we can write the denominator as d square, sorry, a square minus b square into sin x is equals to e power 2x by 2 into 2 minus d by 2 square 4 minus d square into sin x. Again, d square appears in the denominator, so what we have to do? Again, we have to replace d square by minus 1 and the denominator must be non-zero, right? Let's see what happens if we replace d square with minus 1 in the denominator. We'll get 4 minus of minus 1, which is equals to 4 plus 1, by non-zero. Since we got non-zero, so we can dare to replace d square by minus 1. Then yp becomes e power 2x by 2 into 2 minus d by 4 minus of replace d square by minus 1 into sine x, which is equals to e power 2x by 2 into 2 minus d by 4 plus 1 into sine x, which is equals to e power 2x by 2 into 2 minus d by 5 into sine x. Now take this 1 by 5 outside the brackets. We'll get e power 2x by 2 into 1 by 5 into 2 minus d into sine x is equals to e power 2x by 2 5s are 10 into 2 sine x minus d sine x. Since d being differential operator, in the next step we need to find derivative of sine x with respect to x. Now yp becomes e power 2x by 10 into 2 sine x minus derivative of sine x with respect to x. Then yp becomes e power 2x by 10 into 2 sine x minus derivative of sine x with respect to x is cos x. Okay. Therefore, yp equals to e power 2x by 10 into 2 sine x minus cos x, or if you want to write the cos term first and sine term next, then simple. We need to take minus common. Okay. Then we'll get minus 2x by 10, or just don't take minus common. Firstly, just write minus cos x plus 2 sine x. Now you can take minus common from the two terms, and you will get minus e power 2x by 10 into cos x minus 2 sine x. Right? Since minus into minus, plus. Minus into plus, minus. So either you can choose yp as e power 2x by 10 into 2 sine x minus cos x, or yp equals to minus e power 2x by 10 into cos x minus 2 sine x. Now let's write the general solution. We know that the general solution is given by y equals to yc plus yp. Right? So here I'll show you in two cases. Okay, if when yp is e power 2x by 10 into 2 sine x minus cos x, and when yp is minus e power 2x by 10 into cos x minus 2 sine x. So firstly let's see for yp equals to e power 2x by 10, positive, right? Then y equals to yc, we have e power x into c1 cos 2x plus c2 sine 2x plus yp e power 2x by 10 into 2 sine x minus cos x, right? Or y equals to yc e power x into c1 cos 2x plus c2 sine 2x and yp minus e power 2x by 10 into cos x minus 2 sine x, right? You may get any of these two solutions. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.